Hello, this is Christian Byrd,
And Christian Ebner.
and today we'll be presenting on an application of vapor-liquid equilibrium for distillation of a ternary mixture. So our journal article was called Isobaric Vapor-Liquid Equilibrium for Ternary Mixtures of Acetone, Methanol, and Ionic Liquids at a Constant Pressure. And so basically, acetone and methanol are important raw materials that are difficult to separate in a simple distillation setup since they have very close boiling points. And so a method called extractive distillation, which uses an entrainer that breaks the azeotrope of the components to easier separate them. So the journal article investigated the effects on separation performance of three different ionic liquid entrainers that are listed here. And so they're non-corrosive and environmentally friendly compared to other entrainers that are commonly used in the industry. And so what the study found was that 1-methyl-imidazolium acetate produced the highest volatility compared to other entrainers and produce results that are comparable to the more typical entrainers that are used.
So how this study relates to thermodynamic studies. The main focus of this article discusses the separation of the similar compounds methanol and acetone by extractive distillation, as Christian said earlier, which is an important method for acetone and methanol production. This separation process is a very common example of vapor-liquid equilibrium, which helps us determine different concentrations of liquids and vapors within these distillation systems using a modified version of Raoult's law. In this separation, the performance is determined by the volatility of the mixture, which is a function of the vapor and liquid fractions of the two components. Some of the relevant equations for this article and within the realm of vapor-liquid equilibrium are listed here. The first equation is the simple Raoult's law equation, which shows the relationship between solution pressure and the concentration and reference pressure of the solvent. The deviated equation below is the equation most relevant to this article, however, which relates the vapor and liquid compositions to the pressures and activity coefficients of each species. The other two equations, the Anton equation and relative volatility equation, show relationships for saturation pressures within each species and the volatility ratio of each species as well. We've also included our references for this article and all the images listed below.
Thank you for listening in, and I hope you enjoyed our presentation.
Thank you very much.